Good morning everyone. In yesterday class, we completed the phase difference and if two vibrating particles are in same phase. Same phase means in a positive direction. When it starts from its main position and another one is, what means one is followed by the another one. Okay. Here, now we discuss about the opposite phase. I'll draw only one diagram. I'll take care of only one part. It means the two particles moving with one pair. Okay. This is the time axis and the displacement axis is there. It is positive y and it is the negative y when it is moving down. It is called the mean position. Mean position. If the wave, it means if the particle is just vibrating like this, there are two particles. If the two particles are moving, when one particle starts from its mean position and another particle starts from here, one is moving in a positive direction and the other one is moving in the opposite direction. What happened? The phase difference between these two. What is the phase difference between these two? It is, we already know that one form for that. Phase difference between the two vibrating particles is nothing but delta phi is equals to 2 pi divided by t into delta t. It is a form of the phase difference between the two vibrating particles moving. Okay. Now, at mean position, that value of omega t is 0 here. It means the angle is 0. At here, the totally that angle omega t, this is 0 here. And at here it is pi and it is pi and this one is 2 pi. It means the angle made by the particle to complete one revolution, to complete one period is 2 pi. Crest and trough is there. Up to here it is a 4 pi. Okay. Next is the time taken. What is the time here? What happened the time here? The time is at t is equal to 0 here. It means here it is a mean position. Time still not yet considered here. Here time is not yet considered because it is a 0. Then after that, to complete one revolution, the total time taken is t here. Up to t, and finally it is this position and this position, the time is t. To complete half period, this time is t by 2. It means the opposite phase, it means the opposite direction starts from t by 2, 3t by 2 and again here. Okay, if it is 3 by 2, t by 2 and t, it is t by 2 and here to here, it is completely what again? 1t. T plus t by 2 is 3 by 2. It is 3t by 2 is there. Here it is moving opposite. These two are in the same phase. These two are in the same phase. Then what is the phase difference between those two? Okay, we have to calculate the opposite phase at t is equal to, it means delta t is equal to how much? That is t by 2, 3t by 2 and 5t by 2 and so on. These all 1t, 3t, 5t, all are the odd numbers. Finally it becomes what? There are two conditions. One is 2n plus 1 and another one is 2n minus 1. Okay. Then you can take here the 2n plus 1. 2n plus 1 is there. If you write 1, 2, 3, 4, if you write this like this, 2n minus 1. You can take here 2n minus 1 t by 2. T by 2. Where n is equal to what happened? Where n is 1, 2, 3 up to so up to infinite. Okay. Then we have to find the phase difference at these positions at these positions. First one, at t is equal to, that is delta t, the total time is here. Opposite phase starts from here up to here, the t is there, that small t, the phase difference. Delta t is equals to t by 2. It becomes what? T by 2. What is the phase difference? So the phase difference is delta t, delta phi is equals to 2 pi divided by t. Delta t is how much? T by 2. It becomes what? T by 2. Then these two gets cancelled, t gets cancelled. This becomes what? Pi. 1 pi is there. Okay. Next, at delta t is equals to how much? If it is opposite phase starts from here and then here, then it become what? 3t divided by 2. Delta phi is equals to 2 pi divided by t. Then delta t is equal to 3t divided by 2. Then what happened? These two gets cancelled. Again, these two gets cancelled. It becomes what? 3 pi. Similarly, so on. Those become what? 5 pi, 7 pi, and so on. These are also what? Odd numbers. Odd numbers. Okay. These all are the odd numbers here. Again, it is odd integral multiple. Again, it becomes what? 2n minus of 1 times of pi. In yesterday, in same phase, what happened? The phase difference between the two vibrating particles is nothing but an integral multiple of what is that? An even integral multiple of pi. Here, an odd integral multiple of pi. Okay. Next, we are write here some statements of these three. First one is about the phase difference in opposite phase. The phase difference, we have to consider this last condition only. Here also the last condition only. The phase difference between two vibrating particles in opposite phase is an even or odd. It is odd. An odd integral multiple of what? Pi. Completely it is pi. It means what? 2n minus 1 times of pi. Okay. It is 2n minus 1 in times of pi, where n is equal to 1, 2, 3, so. Next, come to the time difference. What happened to the time difference here? The time difference between two vibrating particles in opposite phase is also odd integral. Again, an odd integral multiple of t by 2. It is a half of time period. It is nothing but half of time period. Okay, then it become what? 2n minus of 1 times of t by 2, where n equal to again 1, 2, 3, so on. Then last one is, what about the path difference? Path difference is nothing but it is depends on the displacement of the particle. Okay, the path difference is nothing but delta x. Already you know one form. That form is phase difference divided by 2 pi is equals to path difference divided by lambda, which is equals to the time difference divided by time period. We can equating any two equations here. I will write it. It means what? I will take here these two equations. Equating these two, then what happens? Path difference is equals to lambda into delta t into delta t divided by time is there. Okay. Then the path difference is here. The path difference delta x is equals to lambda into delta t divided by t. Okay. These are the path differences, and another one is okay, the path difference here. Then calculating what about the path difference? Delta t is equals to t by 2. Again the same condition of the time period also. Okay, delta x is equal to what happened? One is the t by 2, another one is 3t by 2, and another one is 5t by 2, and so on. Okay, first one is delta x is equal to, first condition, I write directly lambda divided by t into t by 2. What happened? It become lambda by 2. T by 2 gets cancelled, it become what? Lambda by 2. Then second condition, delta x is equal to 3t by 2. Then what happened? Lambda divided by t into 3t divided by 2, it become what? 3 lambda divided by 2, again 1 lambda by 2, 3 lambda by 2, 5 lambda by 2, again it is odd integral multiple. Again same, right here the same statement of this one. The path difference is nothing but what? The path difference is the path difference between two vibrating particles in opposite phase. In opposite phase is an odd integral multiple of half wavelength. You can mention here it is half wavelength. Wavelength means what? To complete one period, that is wavelength, like this. This up here what? The half wavelength is there. Multiple of lambda by 2, consider as a half wavelength. Half wavelength, or it is also right like this. The path difference is delta x is equal to, direct form is the final equation. The final form is 2n minus 1. Odd numbers are over 1, 3, 5. 2n minus of 1. Lambda by 2 is common here. The lambda by 2. This is the path difference between those two. Yes, in same phase, all right. In same phase and in opposite phase. Okay. Okay. The difference is between those. So how to remember these conditions? Okay. First one is one condition. I'll make one table here. Next is when two particles are in same phase and other one is opposite phase. Opposite phase. Okay. Condition is the first thing right here, the phase difference. Okay. First one is the phase difference. Phase difference, that is delta x. What is the phase difference of this that is same phase? What is the condition for this? That one? All are what? An even integral multiple. Even integral multiple is nothing but what? 2 is even number. Integral is n here. Okay. 2n pi. Even integral multiple of pi. When those are in opposite phase, what happened? Odd integral multiple. Okay. It is 2n minus 1 pi. 2n minus 1 pi. Then what happened? And then another one is in path difference. Okay, path difference is the path difference. That path difference is delta. Sorry, phase difference is delta phi, and path difference is delta x. Okay, delta x in terms of it is a distance. It is in terms of lambda. It is in terms of lambda means in the same phase, those are is an integral multiple of lambda. An integral multiple, lambda is not equal, it is not an odd, it is an integral multiple of lambda where n is equal to 1, 2, 3, 4 to infinity. Okay. Again, the path difference is over. Then what is the path difference in opposite phase? That is become odd integral multiple of lambda by 2. Half of that. Here also it become half of that. It is 2. This become half. Okay, 2n. Here it is lambda is complete full wavelength. This become half wavelength. Then again next one is what is that? The phase difference, path difference both are over. Then another one is time difference. The time difference is delta t. Delta t is here. If both are in same phase, what happened? The same phase that become n times of t. N times of t in same phase. Okay, and integral multiple of total time period. And in opposite phase that become 2n minus of 1 t by 2, half time period, half of that. Okay. We have to remember this table always. Okay, this is very important for. Okay, then the next part is there. When the two particles are both the particle starts from their mean position in same direction and in opposite direction, and by making certain different phases. Okay. We have to consider its mean position. Okay. Then I'll remove this one. One is some condition. One is when two particles vibrating from their mean position. Two particles vibrating from their mean position in same direction. Same direction. What is the phase difference between those two? What is the phase difference between those two? It means what? The one particle is followed by the another one, like this here. Okay, it is 0, it is origin, y-axis, time axis is there. One particle starts from here, from its mean position like this. Like this. The phase difference, we have to calculate the phase difference between those two, okay? And another particle is again starts from their mean position, it means what here also. When another particle is also starts from its mean position like this, the wavelength is constant. Okay, like this. Both are here. The phase of first one is it starts from its mean position. It means delta, this is phi 1 is equals to initial. It is the starts from its mean position. At mean position is omega t is 0. At mean position omega t is 0. If the omega t, the time is 0, it means what? The phi 1 is what happened? This is 0. Then the phase of the second, it means the phase of second particle, that is the phase phi 2 is equals to again what? It is also starts from its mean position. Consider that is also what? 0. The phase difference between those two, it means the delta phi is equal to what? 0. Both are starts from the mean position. The phase difference is 0. The time difference is 0. The path difference is 0. Okay. Delta t is also 0 and delta x is also what? 0. All are 0. The second condition is the two particles vibrating from their mean position, in opposite direction. What it means in opposite direction, how it is, those are moving here. Those are moving like this. This is the y-axis and this one is the time axis called the x-axis. Y is positive here, y is negative here. One is moving from its mean position in a positive direction. Yes, it is right. And another one is moving in the opposite direction from its mean position. Like this. This is moving opposite direction. Opposite direction means one is moving in one direction, another one is moving in the opposite direction. These two are nothing but what? These two are moving, considered as a anti-parallel to each other. Yes, consider these two are in anti-parallel to each other. If these two are anti-parallel to each other, what is the, consider this is the first wave, the first particle, this is the second particle, the phase difference between those two. The phase of the first particle is, it is moving in the first phase, it is moving in a positive direction, it is 0. But the another one is moving in opposite direction, it means what? The opposite phase is there now. Here, the time is 0. The time is 0. We already know one form. That form is here. The time is 0. If those are in same direction, means what? The positive same phase is there. Delta phi is equal to 2n pi. Same phase, t equal to 0 here. Here the t equal to what? 0. If t is equal to 0, what about the time period here? It means t is equal to 0 means what? Starts from here, n equals to initially 0. What happened? It is completely 0 become what? The phi is completely what happened? 0. In same phase and opposite phase. In same phase here. Same phase formula is already there. We have delta phi is equals to, right here. Delta phi is equals to 2 pi. What happened? 2 pi divided by t. And delta t is there. Here delta t is equal to what? 0. Delta t is equal to 0. The whole term become what? 0 here. Okay, it is the phase is 0. This means the phi 1 considered as a 0. Next one is in opposite phase. Opposite form is 2n minus of 1. If here 2n pi n equal to 0, it becomes 0. But here 2n minus 1 of pi is there in opposite phase. Consider here n equal to 0. What happened? Here n equal to 0. This delta phi 2 is equals to n is 0. It become 1 and it is minus 1 because the opposite phase. It is become minus of 1, that is the opposite phase. Or if you take here the plus 1, that become what? Plus. Magnitude is completely plus. Then here delta phi becomes pi, means the total phase. Every time the phase is what happened? The phi. Phi 2 is pi, phi 1 is 0. The phase difference between those two what? Phi 2 minus of phi 1. Phi 2 minus of phi 1 is nothing but what? Phi minus of 0, it becomes pi. Then the phase difference between those two is pi. It means 180 degree. When both are moving in opposite phase, the phase difference is what happened? 180 degrees phase. Here the phase difference is what? 0. Here 0. Phase difference is 0. I'll write here 0. I'll write here the phase is 180 degree phase difference. Okay. Two more conditions are there. When those are moving, it means what? One, I write here only. Your work is here. One is moving like this from its mean position. Its phase considered as a 0, and another one is moving not from its mean position. It is moving from a certain angle, by making certain angle, from a different position, a different displacement is there. It is moving like this. If it is moving like this, it cuts the time axis at here at a 90 degree phi by 2. Directly, where it cuts the time axis, that is the phase difference of that. This cuts the time axis at here, up to here what? Pi. Here only it is 0 and it is 180 degree pi, and up to here it is pi by 2. Where it starts from? One is moving from its mean position, another one is moving from its just like this. It is half of the 90 degree. Half of 90 is here. Then what happened? The phase difference is pi by 4. Like this, the phase difference when those are cuts, where it cuts the time axis, that is the phase difference of those. Okay? Then in next class we will discuss about the next part of this chapter. Thank you.